In today's lesson, we are learning heat and its measurement. Heat is the transference of the amount of thermal energy. The transference of the amount of thermal energy is heat. Okay? So to measure heat, we can just now measure heat. When you heat up a body, meaning we are adding heat to a body, okay, heat energy to a body, all right? Then the amount of heat energy that is absorbed, that is taken, is thermal energy. All right. Then the specific heat capacity is just the quantity of heat that can be absorbed by a body, the specific heat. So I'm going to use this diagram to show you how the specific capacity works and latent heat capacity works. Specific heat capacity versus latent heat capacity. Okay? Very, very important in the measurement of heat. Now, in this diagram, we have that this is in degrees Celsius, temperature in degrees Celsius. At minus 21 degrees Celsius, the liquid has turned to ice block. So around this area, this region is ice block. And once we have ice block, something normally happens. You start adding up heat. We want to melt it. So before you melt an ice block, you must add heat. As you are adding up heat, okay, there is a minimum amount of heat that is needed here. That quantity of heat needed to raise the temperature from minus 21 degrees Celsius to 0 degrees Celsius is what we call specific heat capacity. Because specific heat capacity is the amount of heat energy required or needed to raise the temperature of a unit mass of a substance by 1 degree Kelvin or 1 degree Celsius. So in this case, minus 21 degrees Celsius is raised from minus 21 to 0 as this is increased. So the temperature change here is proportional to the specific heat capacity. So the quantity of heat, Q1, is equal to mass of ice multiplied by specific heat capacity of ice multiplied by change in temperature from minus 21 to 0. So after this has gotten up to this level, we have 0 degrees Celsius, and this is the lower fixed point of water. At this point, we call it Q2. Temperature ceases to increase. Temperature is constant. And when temperature is constant, the amount of heat added will no longer be used to raise the temperature, rather to be used to break the bond holding the solid molecules so that it can melt. Okay, this is called the melting point. So at this point, the ice block begins to melt, to turn to liquid at 0 degrees Celsius until all the ice block, okay, completely turns to liquid. The temperature will be constant. So at this level, when no ice again, no ice block is melting, all have turned to liquid. It is called ice water. Ice water, okay, from solid to liquid. So the liquid at 0 degrees Celsius is called ice water. The effect ice block can give you is what you can get from here. So as from this point, as you add more temperature, more heat, the temperature will begin to change again when this has completely turned to water, turned to liquid. So from here, the temperature will start rising again until it gets to 100 degrees Celsius. So at this point, where the temperature is constant, because we call it Q2, is equal to mass of water multiplied by latent heat of fusion. Latent heat of fusion is the amount of heat needed to change the phase, to change the state of water from solid state to liquid state at constant temperature. So The latent heat of fusion is kind of hidden heat. It is the heat needed to break those bonds. That is latent heat. So at this point, the bonds are completely broken. The solid has turned to liquid. As you add heat further, the temperature will start rising from 0 to 100. So we call this Q3. So at Q3, we generate again specific heat capacity of water. So we have Q3 is equal to MC change in theta. So long as we have change in temperature, we must talk about specific heat capacity, because specific capacity is the quantity of heat required to change the temperature. So to change the temperature, we need specific capacity. Now, we get to this vapor phase, okay, liquid to vapor phase. At this point, you call it Q4, okay? So for Q4, the temperature is also constant. That is the boiling point of water, 100 degrees Celsius. And at this point, the liquid is gradually turned into vapor at constant temperature. And latent heat of vaporization is responsible in breaking the bonds holding the liquid and breaking it out to turn them to vapor. So from here, you will still have mass of ice or water multiplied by latent heat of vaporization. So this is how we can summarize heat and its measurement. In our next video, we shall do a little calculation on I believe the explanation is clear. Any question? Let me see you down in my comment section. Bye.